Hello everybody, and welcome to example 5 on page 49 of the workbook. Okay, and they're asking us in this problem to take the derivative of a function that looks quite a bit more complicated than the functions that we've looked at so far. Okay, so in a situation like this where we're faced with a complicated expression, we sort of want to think about the expression as a whole and ask ourselves, what does it look like? What form is it in? Notice that if you look at this whole function, it's in the form of a quotient, one function divided by another, and that kind of tells us what we need to do to start. We need to apply the quotient rule as our first step here. Okay, so here comes the quotient rule jingle, so we're going to take low d high minus high d low all over low squared. Okay, there's our starting point. I'll remind you that what we really used there was the quotient rule. Okay, now to finish the problem, notice that we have a couple of derivatives to take, one here and one here. If we can do those two derivatives, we're done with the problem. Okay, so let's work through this kind of left to right here. So we were starting with the cube root of t squared plus 1. No derivative to take there. We're done with that term. And what is the derivative of t to the fourth? Well, that's just a power rule. Derivative of t to the fourth is going to be 4t cubed. Okay, and then moving across, we've got minus t to the fourth, and then we come to the derivative of the cube root of t squared plus 1. How do we take that derivative? That's a pretty complicated function. Okay, well, one thing that might make it a little easier is to rewrite it as a power. I'm going to start by doing that. So instead of writing the cube root of t squared plus 1, we can rewrite it as t squared plus 1 to the 1/3 power. That's equivalent to what we started with. Okay, so let me do that. T squared plus 1 to the 1/3 power. How do we take that derivative? Well, notice that we've got an inside function and an outside function. T squared plus 1 is being raised to the 1/3 power. That's a typical chain rule situation. The u is the part inside the t squared plus 1. So we need to actually take the chain rule inside of this quotient rule that we're using. All right, so derivative of u to the 1/3, that's going to be another power rule. It's going to be 1/3 u to the negative 2/3. Okay, and the u is t squared plus 1, so 1/3 t squared plus 1 to the negative 2/3. That's the derivative of the whole function. What is the second part of the chain rule? It's to take the derivative of just the inside part, just the u that's sitting here, and the derivative of t squared plus 1, well, actually, let's just write it first. It's ddt of t squared plus 1. Okay, and all of that's divided by our denominator. Okay, maybe just for the sake of your notes, you might want to remind yourself that this part that I'm underlining, that came from the chain rule. Okay, just the part that we underlined. Okay, and now the question is, what do we need to do to finish this problem? What's left to do here? Well, there's one more derivative that we need to take sitting right there, the derivative of t squared plus 1. Okay, if we can take that derivative, we are done. Okay, so we'll rewrite the parts that we're already done with. Minus t to the fourth times 1/3 t squared plus 1 to the negative 2/3. And then we come to the derivative of t squared plus 1. That's just going to be 2t by the power rule, okay, over the denominator squared. Okay, and looking at that expression, looks like we have taken all the derivatives that need to be taken, and we are done. Okay, notice that's a pretty long expression that we got, but it illustrates how you can use these derivative rules to take a complicated function and to break it down into pieces and step by step arrive at your derivative.